Hello and welcome. This is Michael Annis, and you're listening to episode 95 of the Space Rocket History Podcast. And now, Soyuz Development, Part 4, Politics and Testing. Recapping from episode 94, it is late 1965. The Korolev Design Bureau, OKB-1, is designing the Soyuz to dock autonomously, using existing ground equipment and a new radio homing system called EGLA. Unrealistic schedules are being produced by politicians that don't understand the work and the technical challenges. The politicians' main goal is beating the United States to space records and the moon. The Kremlin, the ministry, and various state commissions are trying to punish those working at OKB-1 for not meeting their deadlines. To make matters worse, the Soviets now realize they have been surpassed by the U.S. Gemini program. As a result of the delays caused by not receiving deliveries from primary subcontractors, the Soviets' plan for manned flights were shifted from 1965 to 1966. The Ministry and the Military Industrial Commission, without having delved very deeply into the state of affairs at OKB-1 production facility, believed that OKB-1 would manage to execute a flight lasting 18 to 20 days in early March of 1966. The purpose of this flight was to regain the space duration record from the U.S. Only Deputy Minister Viktor Litvinov, who had been at the production facility every day, had a good understanding of the real situation. But he didn't dare report the whole truth to the state either. In January of 1966, Sergei Korolev died. His unexpected death was a blow that knocked OKB-1 flat for the entire month of January. Once the team had recovered, OKB-1 once again started up a round-the-clock work regime at the factory on Soyuz production. In January 1966, the minister personally approved the new schedule, replacing Korolev's long-since disrupted schedule from August 28, 1965 of the previous year. The new schedule was painstakingly prepared with Deputy Minister Litvinov's participation, but it, too, was loaded with deadlines that could not be met. In early February of '66, the OKB-1 Communist Party Committee decided to take a look into the status of operations on the Soyuz. Party Committee Secretary Anatoly Tishkin received the necessary instructions in the Central Committee office. He formed a commission to prepare a decision and proposed that Turkov and Chertok give a progress report. Now, a little bit of information on how the party committees and organizations worked. The party committees of large organizations had real clout. They could recommend to an enterprise's administration that the management of one department or another be, quote, strengthened. Now that sounds like a good thing, something helpful, but that is not what strengthen meant. It meant that the current supervisor's career was over and a new supervisor was put in his place. The decisions of the party committee were supposed to be respected. Lower party organizations made sure they were carried out. Lower party organizations' independence manifested itself primarily in the organization of political propaganda, party ideological circles, and the monitoring of the public activities of party members. They had an impact on the production process itself in several ways. They kept track of awarding of prizes and other material benefits. They helped the department supervisor maintain labor discipline. They organized socialist competition, and they took part in the investigation of labor conflicts. If the secretary of the lower party organization turned out to be a decent person, then his activity promoted the cohesion of the workforce and had a positive impact on the fulfillment of the missions. Okay, now that we kind of understand that, let's move on. When it came time for the party committee meeting, first Chertok, the OKB-1 factory manager, and then Chertok gave the situation reports. Chertok stressed the disruption of deliveries from the subcontractors, and Chertok spoke primarily about the internal arrears and the lag in experimental operations. The primary fire of the party criticism was directed to the shortcomings of the factory's work. The commission, which prepared the meeting, did a thorough job, and neither the shop foreman nor the individual managers who had exhibited, quote, irresponsibility and had underestimated the seriousness and complexity of the operations, end quote, escaped their attention. Chertok's staffers were no exception. The commission enumerated the personal transgressions of all of Korolov's former deputies, Rauschenbach, Bashkin, Chitsikov, and Sustov, who had, quote, failed to conduct a systematic analysis of the work of the subcontractors responsible for deliveries of instrumentation and assemblies, and had not been aggressive and persistent enough in making sure deliveries were made, end quote. So, the entire management at OKB-1 was in trouble. The party decreed that comrades Chertok, Turkov, Tisbin, and all the other managers would be held accountable if the schedules were not met. The party decree warned Turkov, Tisbin, and the rest of the production crew that if they did not guarantee delivery of the back orders by February 15th for the production of the Soyuz, the party would hold them accountable as well. So what does a party decree mean in the Soviet Union, where the government of the state, by the state, and for the state prevailed? Boris Chertok described it this way, quote, in those days, the party organizations in industry were not only involved with policy, ideology, and the struggle against nonconformist thought, but tried to get involved in technology and production engineering, wielding real authority over people who were party members. They had the opportunity to affect the production process. With few exceptions, every chief designer was a party member. It was far more dangerous to receive a party reprimand than a reprimand ordered by the head of an enterprise or even a minister. The Communist Party of the Soviet Union was a party of power. This was a party that actively meddled in the production process, not only from the top through the Central Committee or Politburo, but also from the bottom. Things did not always turn out as planned, but as a rule, they had the best intentions. The party attempted to encompass all aspects of a person's life with its ideological influence. Any job was supposed to be a thing of virtue, honor, and heroism, not for the sake of personal prosperity, but to strengthen the power of the state. So long as our motherland lives, there are no other cares. These words, succinctly and rather accurately, reflected the spirit of a myriad of party propaganda campaigns. Any deviation from the party line was punished mercilessly. The party allowed no liberalism within its ranks, end quote. The time of trouble continued for OKB-1 in March of 1966. All the defense enterprises underwent organizational changes, the upshot of which was that their names and post office box numbers changed. OKB-1 was renamed the Central Design Bureau of Experimental Machine Building. The customary post office box number 651 was replaced with P.O. Box V2572. The factory, where Comrade Chertok was director, had a classified name, Factory Number 88. Now it was publicly referred to as the Factory of Experimental Machine Building. NI 88 became the Central Scientific Research Institute of Machine Building, and OKB-2 received the name Design Bureau of Chemical Machine Building. In theory, these new names, without changing location, were supposed to confuse enemy intelligence services. Now it was permissible to use the name OKB-1 only in secret correspondence. It was, however, forbidden to use the name P.O. Box V2572 in documents and conversations classified any lower than secret. While the new name for OKB-1, Central Design Bureau of Experimental Machine Building, could be mentioned anywhere, even at medical clinics, housing offices, and police departments. Now, moving on to May of 1966. After the death of Korolev, the powers that be procrastinated with their decision to name Mission Chief Designer and Enterprise Chief. It wasn't until May 11th that the minister's order came out naming Mission Chief Designer and OKB-1 Chief. Mission inherited the R-9A combat missile, which had been put into service, the RT-2, which had begun flying test, the colossal N-1 launch vehicle, which had been in the throes of birth in the factories, and new piloted vehicles, the Soyuz 7K OK, 7K L1 for the circumlunar trip, and the L3 Soyuz lunar mission. In many respects, the job was much more difficult for Mission than it had been for Korolev. Korolev's authority, his gruff nature, and notoriously predictable reaction to guidelines and all manner of compliance inspections acted as a deterrent against nitpicking by government agency bureaucrats. Now, with Korolev gone and Mission in charge, they had the opportunity to prove how many mistakes OKB-1 had committed. The origin of these errors dated back to Korolev's administration, but nobody would speak ill of the dead. Admonitions and criticisms from the brass usually contain the implication that if Korolev were around, it would have been different. All of this was taking place at a time when the U.S. was successfully completing their Gemini program, and a year later they were supposed to begin flying the Apollo. Under these conditions, the managers of OKB-1 resolved to concentrate maximum efforts on the Soyuz 7K OK vehicles with automatic docking, which were moving forward in terms of readiness. OKB-1 wanted to prove their reliability during the first flights and then refine them. Having made them the sole multi-purpose vehicle for any scientific and military objectives that required the presence of a human being in near Earth space. When he was alive, former Chief Designer Korolev assumed that the 7K OK vehicle would be the basis for the lunar orbital craft for the N1L3 complex. Current Chief Designer Mission continued this line of thinking. The second 7K L1 piloted complex for the circumlunar flight was regarded as a minor thing, a concession to space ambitions. Now let's move on to testing of the first Soyuz. On May 12, 1966, the first Soyuz flight model was ready to begin testing. The testing was planned to take 13 days. Instead, it took 4 months. OKB-1 made it a point not to release the first flight-ready Soyuz from testing until they had eliminated all the defects and glitches. The factory test ended with results that were not as good as OKB-1 had hoped for. 2,000 glitches had been discovered during the testing process. Decisions needed to be made regarding each of these glitches, whether to replace instruments, make cable and structural modifications, introduce changes to the test procedures, update instructions, etc., etc. It is interesting that of the 2,000 glitches, 45% were closed by amending the documentation. 35% required modifications of onboard instruments and cables, and 20% required modification of ground testing equipment. At the end of August, the first Soyuz was removed from the testing facility and sent for stowage and assembly operations before being shipped to the firing range. There were still a dozen glitches that hadn't been completely sorted out. Testing lasted so long that many subcontractors, having discovered their own mistakes, used the time to modify the instruments before delivering them to OKB-1. The Soyuz 7K OK was the first spacecraft whose factory tests were notable for a substantially greater degree of depth, and the process of troubleshooting identified defects was made easier thanks to the use of a universal testing complex called 11N6110. On the Soyuz, for the first time, the Soviets fully appreciated the advantages of this ground testing complex. A new ground testing stand was also created called the Cardin. It was a massive structure that accommodated the Igla, its gyro-stabilizing antenna, and the vehicle's main gyroscopic instruments. The platform holding the hardware was installed on the inner ring of the gimbal mount. The Cardin's 3 degrees of freedom made it possible to simulate the behavior of Igla and the attitude control system and their phasing and operation while simulating the various positions of the active vehicle. This test cycle took 2 or 3 months of testing, a month for packing and shipping, and another 2 months of round-the-clock rush jobs at the Cosmodrome engineering facility. In all, it was 6 months after the official end of the production cycle. The explanation for the lengthy time in testing was simple. Before the first flight model was manufactured, a precise engineering analog would have to be manufactured. It would be used to practice the test procedures, to find and correct all the design errors, circuit tie-ins, and cross-couplings, to modify test equipment and update the testing instructions, to make all the repairs to flight complex equipment, cables, and instruments, and only then to set about testing it. Also, the flight of each spacecraft was its first and last. Everything had to be foreseen, anticipated, and tested. All nominal and off-nominal situations in a spaceflight had to be accounted for to make sure that the complex combination of spacecraft systems would enable the crew to safely return to the ground. In June of 1966, testing began on Soyuz 7K OK No. 2, just a month after No. 1. Staggering the dates like that was sufficient to reduce the number of defects and glitches on No. 2 to nearly half that of No. 1. During the period from September through November, 7K OK No. 3 and No. 4 passed through testing. Progress was obvious. The total number of glitches was 736 for No. 3 and 520 for No. 4, and the testing time was almost 1/3 that of No. 1. Rush jobs at the factory did their part. From September through December 1966, 4 7K OK vehicles were shipped to the Cosmodrome. The military testers at the Cosmodrome longed for real work. They greeted the OKB-1 specialists like long-lost friends. At the Cosmodrome, people gathered from more than 50 different organizations from many different cities over the course of 10 years of work at Tyratam. Not only the rocket veterans, But also the neophytes learned to understand one another surprisingly quickly, diving right into the commotion. For the sake of deadlines and schedules, the chiefs of testing and lead designers developed a dangerous self-confidence. If all the tests had been conducted in accordance with approved instructions and methods and had produced positive results, then any new initiatives among skeptics were stopped. Yet life had shown one should never disregard proposals for additional tests. In October of 1966, spurred on by American successes in the Gemini program and the latest reports about progress in the Apollo program, senior management was uneasy about the lull on the Soviet space front. By autumn 1966, the break in Soviet manned launches had lasted a year and a half, and no one had dared name the precise date for the next sensational flight. There had never been such a lull under Korolev and Khrushchev. From March 1965 through September 1966, the Americans had launched their Gemini spacecraft into space 9 times, each one carrying 2 astronauts. In all, if you started counting from the Mercury flights, the Americans had 21 astronauts, and 3 of them had each flown twice. So, in terms of the number of astronauts, 21 astronauts versus 11 cosmonauts, and the total number of piloted flights, 15 for the U.S. versus 9 for the Soviets. The Americans had shot far ahead. The U.S. announced that the last Gemini flight would take place in November 1966. It would last up to 4 days and carry astronauts who were preparing for an Apollo flight. Speaking before Congress, the President of the United States reported about the successful progress on the Apollo program. He assured Congress that the U.S. had achieved space supremacy, but in order to hold on to it, they needed to speed up the Apollo program. Central Committee Secretary Ustinov made a promise to General Secretary Brezhnev to deliver new, magnificent triumphs in space, counting solely on Soyuz. The uneasiness of the party and the government leaders could also be attributed to the upcoming anniversary year. The 50th anniversary of Soviet rule was going to be in 1967. This was supposed to be celebrated with great achievements in all areas of economics, science, and culture. And suddenly there was a lull which was so incomprehensible for the Soviet people and for the nation's higher political leadership. To respond to this directive, OKB-1 Chief Designer Mission held a meeting. Chairman of the State Commission, Tyulen, came to the meeting. After reviewing all the proposals for the scheduling of upcoming launches, Tyulen warned that in October this matter would be put before the Collegium of Ministries with all due seriousness. Tyulen's boss, Afanasyev, had told him that he intended to severely criticize Mission and everyone who was guilty of the complete breakdown in the piloted launch program. After the panel, a discussion of this matter in the Military Industrial Commission was inevitable, and then a report to the Communist Party Central Committee would follow. Tyulen added, "They're expecting us to resume piloted launches this year. Instead of you, the Americans are getting a gift ready for the 49th anniversary of the October Revolution. They have announced the flight of Gemini 12 in early November. There was never such disgrace when Korolev was around. For the 50th anniversary of the October Revolution, we have been assigned a mission to execute a piloted circumlunar flight on the 7K L1. And in 1968, a moon landing. Unable to hold his tongue, Chertok remarked that the Americans had already passed the Soviets in terms of the number of piloted flights and astronauts when Korolev was still alive. Chief Designer Mission pledged that we would launch the first pair of Soyuz to perform a docking in October of this year, 1966. If the Soyuz achieved autonomous docking in space, then the Soviets would pass up the Americans in this area. As Taulin had promised, the collegium really did meet. OKB-1's work on the Soyuz 7K-L1 and the Soyuz 7K-OK was declared unsatisfactory. The ministers summed up the charges against OKB-1 as follows, quote, Korolev guaranteed us that the 7K-OK would be launched in the spring of 1965. Soon it will be 1967, and we still have no spacecraft. OKB-1 and Mission were overconfident. They believed they were above directives from the Central Committee. End quote. Soon after the collegium, a military-industrial commission session took place in which a directive from the higher-ups designated Luna as mission number 1. At the meeting, Gregory Babkin's latest achievements were held up to us as an example. In addition, Chalomy's proposal for circumlunar flight, which OKB-1 had allegedly obstructed, were mentioned. And once again, the following mantra was repeated, quote, "Don't give away the moon to the Americans," end quote. None of the managers standing over OKB-1 in the administrative and party hierarchy, particularly Central Committee Secretary Ustinov, Minister Afanasyev, and their deputies, were outsiders by any stretch of the imagination. Each had passed through the rigorous school of arms production during the war. Individually, each of them understood the difficulties we faced, and in their own minds realized how unrealistic it was to attempt a piloted circumlunar flight in 1967 and a moon landing in 1968. But as soon as they gathered for the official meetings with the actual executives in attendance, they gave in to a sort of collective hypnosis and demanded the impossible. At one point, Chertok couldn't stand it any longer, and during the next one-on-one meeting with Deputy Minister Taulin, he remarked that, quote, "No one would propose a Central Committee resolution to shorten a woman's pregnancy from 9 months to 6 in order to increase the population. They could send you to psychiatric hospital for such an initiative. And here they are essentially demanding that we develop a highly sophisticated system with unrealistic deadlines." Taulin replied, "Don't get any ideas about spouting off anywhere like this. It was Sergei Korolev who proposed these deadlines in his day, not the Central Committee." About 10 days later, a terrible decision circulated, once again committing the participants of the Soyuz 7K-L1 and N1L3 lunar programs to complete all work in the lunar spacecraft and the launch vehicles as top priority and as especially crucial state assignments. Thus, another delay for the first Soyuz docking test. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. Thanks.